All right, this is a screencast for the Graphing Your Motion lab that you most likely will be doing tomorrow. What will you be doing in this lab? You'll use a motion detector to measure position, velocity, and acceleration. What is a motion detector? It's a device that you'll set on the desk. It gives off a sound wave that the sound then travels and then it will strike you as you stand in front of it. When that happens, the sound will be reflected back and then it will receive that sound wave. And by knowing how long the time it takes for that sound wave to hit and bounce back, it can calculate the distance away from you are from the detector. Now, real quickly, how can it do that? Well, it's basically our speed triangle where we have speed, distance, and time. And if we want to know distance, so in this case, distance, we cover up d, and that means it's going to be speed times time. Speed times time. Well, the speed of sound is a constant through air at sea level. So it is going to stay the same. And so because we know the speed and the time, it's a very accurate timer on how long it takes for that sound wave to bounce off. We also know the time. And from those two, we can calculate the distance. So if the speed, let's say, is in meters per second, and we know the time it takes in seconds, the time cancels and we're left with a distance in meters. And that's the way that works. It's basically echolocation. A bat or a dolphin would be doing the same type of thing. Okay. Now, what else will you be doing? You'll use a computer to produce your graphs of your motion, analyze the graphs you produce, and match position versus time and velocity versus time graphs. Now, make sure you won't have to fasten it to the tabletop, but you need to connect the motion detector and make sure everything's set up, and make sure the sensitivity switch is set to normal. You'll place masking tape on the floor, the blue tape, at 1, 2, 3, and 4 meter positions. So you'll have that marked off: 1 meter, 2 meters, 3 meters, 4 meters, etc. All right. Now, what you will do is you will go to the file in the Logger Lite program, and it's the file button, and you'll select the 33A Graphing Your Motion. When you do that, this will come up. It's a distance versus time graph, and it says stand at the 1 meter position facing the motion detector and the computer screen. Have your partner click collect. Slowly walk backwards away from the detector and watch the screen. So as you slowly walk away from the detector, all right, you're going to find that it is going to make a line that will look something like this. If it doesn't look very good, if it's a bad line or a curved line, then just do it again. And remember, walk backwards at a constant speed from the detector. Then hit the Store Latest Run button, and then repeat step 4, which is but this time you're going to be moving faster. So you will then hit your Store Latest Run. This will stay up, and then you will do the same thing, but this time you'll do it faster. All right. And you're going to sketch your results, not your partner's, but your own results. I want everybody to do this in the graph above. And you should have 2 lines when you do that. Then you're going to go to 33B graph matching. You will see the following position versus time graph. Notice distance is on the y-axis here. Time is on the x. And you are going to try and match this by either standing still, moving toward, or moving away from the detector. So maybe on the first try, it's not anywhere close. All right, that's fine. Then repeat it as many times as you need to where when it takes the data, it somewhat approaches the line that's on the graph. Okay? Then have everyone in your group try and match the line, and you will draw your own data on this graph. Then describe the difference between the 2 lines you made On your graph in steps 4 and 5, please make sure that you're on the right steps when you do that. 4 and 5 refers to this first graph and these lines up here. And then explain. So often students forget to explain why the lines are different, right? Don't forget to do that. Now, you will next, how would you graph change? Oh, excuse me. How would your graph change if you walked towards the motion detector rather than away from it? Test your answer. So try that, and then you'll for sure get the right answer when you write that in. What did you have to do to match the graph you were given in step 7? Well, that would be this one right here, and you need to be specific. What did you have to do at this point? What did you have to do at this point, this point, this point, and this point? So you're going to talk about all these things. And one other thing, notice that here, the slope of this line is different than the slope of this line. So probably it has something to do with the speed you were moving. So make sure you refer in that question to the speed at that point. Then you're going to do velocity versus time. This changes. Notice velocity is meters per second on the y-axis now versus time, or with time versus velocity. Notice you also have negative numbers in this graph. The reason for this is because velocity is a vector quantity. Remember, it has both a magnitude and a direction. So if you were walking away from the motion detector, all right, and I'm not going to give this away, but it may give you a positive value, or maybe it's a negative value. But when you switch directions and go the opposite direction, then you're probably going to get an opposite deal. So if this happens to be negative, this would be positive. And if this was positive, this would be negative. So pay attention to that and realize that's what that means. It just has to do with the direction. Remember, vector quantity has both an amount and a direction. Thus, it's represented by a vector. Okay, then you're going to do the same thing. You're going to stand at the 1 meter position facing the motion detector and the computer screen, have your partner click collect, and then slowly walk backward away from the detector. Choose the store latest run. Repeat step 10, however, moving faster this time. And then, just like you did above, sketch your results on the graph. Then you'll go to the matching the velocity. I think you get the idea. You'll try to match this line on the screen. And then you're going to processing the data. You're going to describe the difference between two lines on the graph made in step 10 and 11. And then once again, explain why the lines are different. Definition of velocity, you can get that right out of your book. What did you have to do to match the graph you were given in step 13? Remember, talk about the specifics of what you had to do. How fast were you going? Which direction were you going? Were you standing still? How far away were you? Those types of things. Next, this one, describe the motion needed to make this graph. Well, since this is a position versus time graph, you're going to have time on the x and distance on the y. That, when you talk about how to get this, if you were to match these three lines, you're going to need to be specific. But it will be different now for this velocity, because this is if you were matching velocity on this axis and time on the x. Go back to what you saw in the last two examples, right? Trials, and see what made these types of patterns, and then describe. And once again, there is a different slope here between 1 and 3, well, and 2 for that matter. So be specific on how these would differ, how you would get these different slopes. And then you can check your answers using the motion detector. Finally, acceleration. This part you're going to use on 33E, graphing motion. I think you get the idea on what to do at this point. We'll close it out. Just make sure you read the directions specifically. And then when you answer your questions, you answer the questions completely. And you should do just fine. All right, that's it.